Yeah, thanks, Puneet. The title of the talk is A Break in the Case of Old JRoot Query Traffic. So JRoot is one of the 13 root server identities. And back in 2002, its IP address was changed in order to support multicast, anycast. And this is something that has been presented a few times here and other places. You can see these slides here on the screen now are from a 2004 presentation to NANOG. And the point of this presentation was that 2 years after the address was changed, we were still seeing 1,500 queries per second on the old IP address. And then in October 2015 at a DNS-OARC, there was another presentation called 13 Years of Old JRoot. And at that point, we were still seeing 500 queries per second. And this was, this was ongoing, still very puzzling. Didn't quite understand why. Here's some current data going to mid-2025. And we still see about 350 queries per second to the old address. I think I'm supposed to stand here. So as a quick sidebar, if anyone by chance doesn't know what root server priming is, here's a brief description. So DNS resolvers need to know the addresses of all the root name servers. When they start up, they might have out-of-date information, so they send a priming query to one of the root servers. The root server sends back the current list of root server names and addresses. This is all described in a fairly recent RFC called Initializing a DNS Resolver with Priming Queries. So that's how it's supposed to work. The Root Server System Advisory Committee has been talking about a topic since about 2015, 2017 of changing the names of the root server addresses. So this is something RStack worked on for a couple years. In 2017, RStack wrote this document, RStack 028. It had a recommendation for further study on the topic. That further study took a while to get done because of various things like global pandemics and whatnot. But that report was finally produced in 2024, and it had this this sort of, I don't know, almost passing comment in it, which was that this version of bind 9.9.1 and Power DNS, these other versions, failed to learn new IP addresses for root servers in the additional section of the priming responses when the names didn't change. And I kind of saw this and went, could this be the reason that we still see traffic to the old JRoot address? So that report mentioned just one version of bind, and my goal was to see if it was more prevalent than that. So you see a lot of white space in this slide. I want you to imagine that there's a really clever meme here, maybe with Darth Vader, that got removed by somebody's corporate marketing department, not approving the use of memes in presentations, but it was really good, let me tell you. Okay, so I proceeded to test a lot of versions of bind. I configured them with wrong hints. I basically gave every root name server the address of old JRoot. This was a test done on the internet. For each time, started a background packet capture, started the name server with the wrong hints, sent it a few queries, checked the logs, and then repeated that for every version of bind that I could compile. DNSSEC was disabled to make comparison easier for versions that predated DNSSEC. So this screen, which some of it may be too small to read, but you can see here, this is a sample packet capture. This is output from T-Shark. And in red, the red highlights the addresses of old JRoot. These are queries to sort of the wrong root server. In blue, it highlights the priming queries or the priming response. So this is from bind 9.2. And you can see there's a couple of initial queries to the old address. There's a priming query and a priming response. And then we continue to see queries to the old address, right? Even after a few seconds, 5 seconds or whatever. This is from bind 914. There's more packets here, but again, you can see queries to the old address. There's a priming query, which in this version of bind, it's actually sent with a small UDP buffer size, so it gets truncated. That's why the 545 is highlighted there. That gets retried. A couple more queries to the old server, and then we start seeing queries to the current IP addresses in green. Right? So this is how it's supposed to work. So like I said, I did all these tests to all the versions of bind I could compile. And so this graph shows bind 9.2 to 9.8, and they all have this property where they only ever send queries to the old addresses. This graph continues 9.9 to 9.13, and here we start to see some things change, right? So from here, I can't quite read it. I think it's 9.9 something to 9.10. We start seeing versions that will sort of do the right thing and start hitting the up-to-date addresses. And then here's the rest. I guess this stopped at compiling versions of bind 9.7, but all of these work the way that we expect. Okay, so in addition to that, I wanted to do a sort of simple analysis of client IP addresses that are sending queries to the old JRoot address. And that's what these graphs are designed to convince you. I'm not sure they achieve that exactly, but on April 28th, when this work was done, there was 42,500 IP addresses that were querying the old JRoot address. And 75% of those, so about 30,000, sent 0 queries to the current address, the new address. And those were responsible for 62% of traffic to old JRoot. 80% of those old clients sent 10 times more to old JRoot than the current JRoot, and are responsible for 80% of the traffic. So that graph on the left is kind of showing that, but you can kind of tell that it doesn't look like there's very many more. It doesn't look like there's 42,000 dots on that picture, but there's a lot that are co-located down in the corner of the axis there. The graph on the right shows for each one of those 42,000 clients, basically it ranks how many queries it sent to those addresses sent to the old JRoot address, the current JRoot address, and the ARoot IP address. And the green line represents the current JRoot address. So again, much fewer queries to the current address than the old one. So in addition to that, I thought it would be interesting to send hostname.bind queries to all those sources. Again, of the 42,000 or so, well, so I only picked the ones that sent more than 10 queries per day. So I guess that's about 14,000. A lot of them didn't respond, got a lot of timeouts, 80% timeouts. 18 or so percent did respond. Some of the responses were not useful. They were refused or form error or whatever. About 14% had an obfuscated version string, like, you can't be serious, or, go away, that kind of stuff. It's very entertaining to read those if you've never done it. But just under 2% had an unobfuscated hostname.bind response. And that's what the subtable sort of breaks down. So most of those, again, they were bind 9 in the sort of what I call the unpatched range, the old versions, and a small percentage, maybe 15. Again, I need my glasses. Small percentage were in the patched range, but most of them, again, indicated the older versions of bind. And then there was a smattering of other version strings there as well, PowerDNS, NSD, and so on. So in addition to that, I use the FPDNS tool, which some people may be familiar with. Like I say here, this is a really old, unmaintained tool, and you should probably never use it. It's it's kind of okay in this case because about the time that FPDNS stopped being maintained was about the same time that this version of this problem in bind appeared to get fixed. So again, I sent that, used that tool on those clients that sent more than 10 queries per day. A lot of timeouts. Of the ones that did not time out, you can see broken down here that 70% or 70 something percent indicated they were bind 9.1 to 9.7. There's also a pretty significant percentage that were identified as Milioff Vinigan Posadas. And if you go to the FPDNS page, you'll see that there's an open bug report for the last, I don't know, 8 years, saying that it's misidentified. So that's really also probably these older versions of bind in that group as well. And then there's a few others lumped in there as well at the end. So I'm almost done. My conclusion is that all versions of bind released from 2001 to 2017 appear to fail root server priming as described in that RSAC 028 implementation study report. Starting around 9.9.12, we start seeing the behavior that we'd expect, where they query the root name servers. Our data at Verisign supports the theory that those sources hitting old JRoot are failing to do the priming, and we think that any version of bind from that era that's still running will continue to query the old address and probably never pick up the new one. On the right here, you can see a copy of the commit log from named, which I think is when this bug was fixed. If I could read the screen better, I might read it to you. But basically, it talks about how the priming data was not being trusted and not being accepted, and causing clients to require the old addresses over and over and over again. Here's a couple of URLs referencing things in the talk, and that's it. So, right.
I'm confident.
We have about 5 minutes for the questions.
I'll be quick. Is this on? All right. So I love this stuff. Thank you for the presentation. We already chatted about this before. My name is Roy Adams. I work for ICANN. There's a small question I have. Most of these versions come with baked-in hints, right? And these baked-in hints are the correct hints. They're not the old hints. So I assume that those that deploy these old versions still must have an old hints file that they use, and that is failing to update. Is it correct?
I think so, but I'm not sure what you mean by baked-in hints being correct. They were correct at the time.
So the bind 9.9 version that was released way after 2002.
Yeah,
that contained the correct hints internally. They are baked in. If you don't have a hints file, it uses baked-in hints. So my question is,
right.
You need to have those old hint files still stored on disk somewhere in order to be able to use them.
Right. So I think this would be more of a question for ISC folks, but I think that the hints file would override the hints in the code, if you will. Right. So that I guess the supposition is that the hints file didn't get updated even if the software did.
Gotcha. All right. Thanks for the clarification.
Hello, Joe Abley, Cloudflare. So you had a lot of clients that you couldn't query because you got timeouts. And it's been a long time since you could reliably say that one address is one client and not 10,000 clients, for example. Did you do any comparison of your source address list that you saw at JRoot and compare them with lists of known NATs, things that have like exhibited other NAT-like behavior, to see if you could sort of discount that? Because you may have those addresses may have multiple different bits of software behind them. Maybe eliminating those or doing something else to eliminate the bias might be useful.
No, I didn't do that. The only thing I did sort of along those lines was in one of the slides, looking at IP addresses that queried the old JRoot and also queried A root. But I didn't try to differentiate ones that were maybe serving multiple clients behind NAT or anything like that.
Right.
Yeah.
And just to follow on from Roy's point a little bit, I mean, I guess a new version of bind that has an old hints file might send a query to an old JRoot address once in a while to prime, then might interpret the results correctly, and then might send subsequent queries to the current JRoot. So that's part of the theory here.
Right. I think that's correct, but that wouldn't happen until 2017, right? Until a version released after 2017. Yeah.
Hi, Mark van der Wal from Afnik. Have you tried other fingerprinting tools besides FBDNS? Yeah.
I have not. Are you aware of some that are good?
Yeah, I know one that's actively being maintained. So I'll talk to you about it later.
Okay, sure. Yeah, I'm a little bit like Joe just said. Fingerprinting these days is kind of hard because now clients properly block queries coming from outside their organization, and that's what we want. So, like I said, 80% wouldn't answer anyway. But yeah, I would be curious to know if there's a better fingerprinting tool out there. That's
okay. I can try to find you on Mattermost and send you.
Sounds good. Yeah, thanks.
All right.
Petrus Pocek, I see. Thank you. Very interesting. From our experience, we know that operators quite often have new version of software and very old hints file, which predates even the person on the job because, it was there when they started and they don't dare to touch the file. So some of the queries you see might be like the first priming query, which, accidentally picks file from like 2005 because it's on disk, and then it goes away. So that's basically what Joe said. And I'm just saying that we see in our support customers very old files, and then we get weird questions. So why is this query sent to this old DARPA address, which has reverse records saying do not use or something weird? And so part of it will be noise.
Yep.
But at the same time, I very much believe that there is lots of very old versions running all the time.
Yeah. Thanks, Peter.
We have 20 seconds, and I have one quick question for you.
Oh, I know your question.
So do you plan to keep this around for fun, or do you plan to turn it down at some point?
Well, so every time this comes up internally, we have a debate, and I can't say either way, to be honest. Since the old JRoot address is on the same /24 as a root address, it's very easy for us to just answer those queries from the a root service, right? It doesn't require any extra infrastructure really for us to answer those. It's really kind of a philosophical question about, what's the right thing to do? Is it better for the internet somehow to stop answering these, or is it better to keep answering them to allow those clients to work? And we can't come to agreement internally. So, yeah.
My opinion would be if you turn it on, maybe these people will fix their hints.
Maybe, yeah. Thanks.